Hello everyone, this is a pre-recorded talk. I'm going to talk about magnesium and carbon-oxygen isotope variations during magma-carbonate interaction at Jinchuan. Jinchuan is one of the largest magmatic nickel-copper sulfide deposits, but for Jinchuan, the direct evidence for external sulfide has never been solidified. So Harman 2007 proposed a model. CO2 were derived by assimilation and de-carbonation of country rock marble. CO2 caused the magma oxidized. The oxidized magma reduced the ability to dissolve sulfide, and therefore the sulfide saturation was resulted. Magnesium isotopes of marble and metal-derived magma are significantly different, so magnesium isotopes are believed to be useful to evaluate the assimilation process. Tang 2018 reported radiogenic isotopes and magnesium isotopes for intrusive rocks from Jinchuan and concluded that less than 10% of marble were involved in the formation of Jinchuan. However, the weighted magnesium isotope ratios are in limited range. The weighted value very close to the value of metal. In order to test the role of marble in orogenics, and in order to test the magnesium isotope behavior during the marble-magma interaction, we analyzed carbon-oxygen isotope and magnesium isotope ratios. This study focused on the samples connected from the contact zone. The analyzed sample include marble, xenolith, and hybrid rocks in the contact zone, and intrusive rocks from the margin. We also connected the samples from the underground, the interior of the deposit. The figures show the country rocks and the contact zone of xenolith and hybrid rocks. Both the size and the shape of xenoliths are varied. The xenoliths also have very sharp contact with the surrounding rocks. The country rock marbles are composed of dolomite with a small amount of calcite. In the contact zone, xenoliths consist of diopside with minor amounts of calcite. The original marble has already been decarbonized. In the contact zone, xenoliths are also present within hybrid rocks. Some hybrid rocks contain isolated olivine and pyroxene grains, which are distributed irregularly in the matrix, and others show large patches of olivine surrounded by the matrix. The matrix is enriched in calcite with small amounts of dolomite, as well as small grains of olivine and pyroxene. Mineral assemblages of the intrusive rocks are composed of olivine, pyroxene, and plagial clays. We analyzed the major element compositions. The plotted data are recalculated in 100% volatile-free basis. The composition of parental magma is also plotted. The composition of xenoliths and hybrid rocks from the Harman 2007 are also plotted. There are 4 trends here. There is one trend starting from the parental magma to intrusive rocks, indicating the process of fractional crystallization. The other 3 trends are the one following the trajectory of the marble, the one between the composition of marble and intrusive rocks, and the last one between the end of marble trajectory and intrusive rocks. Here are isotopic results. For carbonate minerals, those from xenolith and hybrid rocks in the contact zone have lower oxygen and carbon isotopic ratios than those from marble. In contrast, the variations of magnesium isotopic ratios in carbonate minerals is very small. For pyroxenes, the oxygen isotopic ratios from the margin and the interior of the intrusion show limited range. Pyroxenes in the intrusive rocks have magnesium isotopic ratios very close to the Earth's mantle. Compared with the results of TON 2018, most samples are consistent within the error range. However, the measured values of TON 2018 are systematically lower than our result. They have measured whole rock magnesium isotopic compositions of hybrid rocks at variable distance from marble xenolith. The measured isotopic ratios of most xenolith and hybrid rocks are close to the value of country rock marble, but there is one exception, as high as -0.9 per mil. Here is another example of whole rock magnesium isotopic compositions of hybrid rocks at a variable distance from marble xenolith. Now we move on to the discussion part. Carbon and oxygen isotopic values are clearly evidence for the decarbonation process. Using the Rayleigh fractionation model, the integrated carbon fractionation between CO2 and carbonate is estimated to be 3.2 per mil at 550 Celsius. The integrated oxygen isotopic fractionation between CO2 and carbonate is around 6 per mil at 550 Celsius. We also record reactions based on mineral assemblage and phase diagrams. First, at the conditions of no silicon activity and CO2 activity, reaction 1 is stable, and dolomite is converted into diopside. Once xenoliths were captured, reaction 1 progressed, and CO2 was generated. Second, formation of olivine by reaction 2 occurred over a very restricted range of both silicon activity and CO2 activity. Reaction 2 did not proceed until there was enough supply of silicon for the melt and significant degassing of CO2 from the reaction 1. Third, reaction 3 records the conversion of dolomite into magnesium melt and CO2. Now we rationalize what happened for the magnesium isotopic compositions. For pyroxene in the intrusive rocks, their values are in the mantle range. For carbonate minerals from xenolith and hybrid rocks in the contact zone, they are consistent with the marble values. For whole rock of hybrid rocks in the contact zone, most of them are consistent with marble values, but there are exceptions. We think the abnormal values may be local deviations. Considering the interactions between mantle, derived magma, and assimilated endmembers, the assimilated endmembers can be marble, decarbonated product, or magnesium melt. The mass balance calculations show that they all required significant contributions of mantle-derived magma to reach the local deviation values. The combined effects of dolomite breakdown and the mixing of country rocks were responsible of the observed magnesium isotopic ratios. But they also record the sharp differences between the contact zone and the intrusive rocks. The carbon and oxygen isotopes behave different from the magnesium isotopes. During the decarbonation and dolomite breakdown, the contribution of silicon from metal-derived magma correlated with the release of CO2 and associated decrease in the oxygen isotopic values. However, the magnesium isotopic values of carbonate minerals are consistent, even though the whole rock and metal ratios varied. Unlike carbon and oxygen that are able to migrate out of the contact zone, the deviation of magnesium was fixed in a restricted area. Metal-derived magma supplied elements that was required for the chemical reactions as we observed. The local abnormal in magnesium isotopic ratios in whole rocks of hybrid rocks in the contact zone demonstrated the contribution of magnesium from metal-derived magma, but there is no evidence for the transport of magnesium from the contact zone into the intrusion. They suggest that magnesium isotopes appear not to be a good tracer for the ore-forming process in the formation of Jinchuan magmatic system. Heating by metal-derived magma results in partial melting and decarbonation of marble xenolith, causing no density and no viscosity CO2 transported into the magma, but there is no isotopic evidence for magnesium move away from the reaction front, where we think CO2 bubbles can efficiently transport away from the xenolith, but the contaminated magnesium melt was confined in the contacted area.